Okay, hello everyone. Let's take a look at problem 25-5A, where we're going to, in this brief demonstration, handle requirements 1 and 2, which is to determine the contribution margin per machine hour for the Ortiz company that sells 2 products. And then on the second requirement, we will answer the question, how many units of product G and product B should the company produce if it continues to operate with only one shift, and how much total contribution margin does this products mix produce? Okay, let's take a look at the contribution per machine hour. This one is really straightforward. We have the data in front of us. To the left there on product G, selling price is $120, variable cost is $40, leaving a contribution margin of $80. It takes 0.8 hours to make 1 unit of product G, and the maximum unit sales is 400. Okay, so if we want to determine the contribution margin per machine hour, all we really have to do is take the contribution margin per unit. So let's just write that down and do that. And that contribution margin per unit is equal $80, right? And the machine hours to produce per unit, why don't I just say per unit, is 0.8, right? So if we need to compute the contribution margin per machine hour, and I'm going to abbreviate here, we simply divide the $80 divided by the 0.8, and I will turn that one into a dollar and this one into a dollar. We'll just do an underline even though it is a multiplication. Okay, let me move this over so we've got a little bit more room to see it. And that takes care of the answer for product G. We can label that product G there. Let's do the exact same thing for product B. Only in this case, we've got $70, and it takes 2 hours, so we've got a $35 contribution. Okay, let me just bold that and get rid of the decimal places. We really don't need that. We really don't need the decimal places on these either. Okay, so there's the answer to part 1, which is to compute the contribution margin per machine hour. Now, let's take a look at problem 2, which is how many units of G and B should the company produce if it continues to operate with only one shift. Okay, and we know that a typical month has 22 days, and they're only operating one shift. All right, so what we need to do is figure out how many hours. Well, first off, the answer to the question is very simple. They should make as many products of G as possible, and they should make none of products B. They make more money on product G. Now that's the simple on the surface answer. Now let's compute the maximum output of G. Okay, well, we've got 8 hours times 22 days, so let's just do it this way. Let me draw a line here because I don't really want to scroll, so that we'll tackle the second problem down here. In fact, I'll take the line all the way over, so we know now we're dealing with part 2 down below. And let's just say we have hours, right? Hours per shift is 8. We have number of days per month. Okay, let me move this over. Number of days per month is 22, so that leaves us with total hours per month. Caps will behave themselves. And total hours per month, we just simply multiply the 8 times the 22, right? That gives us 176 hours. Now, we need to determine what's the maximum output. Well, maximum output is going to follow a little formula. and I've copied that off the side so I don't have to type it. Maximum output would be number of hours times units produced per hour, right? So if we were to solve for that, we would need to then solve for equals 176 times the units produced per hours would be equal to 1 over 0.8. Everyone see why I'm inverting that? If it takes 0.8 units to make 0.8 of an hour to make 1 unit, then if we take 1 divided by 0.8, we know that we can make 1.25 units per hour. Okay, let me delete that 1.25, and then let's just enter the formula, which would be equal 176 times 1 divided by 0.8. Now we could have just taken the 176 divided by 0.8, get the same result. And there's the answer to part 2, which is, in this scenario, we'd want to make all of product G, and the maximum output we would make is 220 units. Now, what would be the contribution margin of this? Well, that's real easy, right? Contribution margin, in this case, would be equal to the 220 units times the 80 bucks. So why don't we take the 220 times the 80 bucks, the 80 bucks from above, which comes directly from the table where we've already done the calculation. And I will bold that. Hopefully it will fit. Oh, it's not, so I'm going to slide this a little bit. And the final answer to parts 1 and 2 appears in front of you in bold. Thanks, everyone. I hope you found this beneficial.